Okay, hello everyone. Today is day 8. Should be watching this actually before day 8. We're looking at standard deviation. Today's objective, guys, we're going to quantify and analyze the spread of data from the mean now. Remember, we've been doing it from the median. All right, looking at the IQR, looking at our box plot. Well, now we're going to analyze the spread of data from the average, from the mean. Okay? Today's essential question, is there a way to measure how a set of data varies from the mean? Is there a way to do that? Well, of course there is. All right, we have talked about two different measures of spread. We've talked about the range, and the range is the max minus the min. That's the total range from the biggest to the smallest. And then we looked at what's called the IQR, or the interquartile range, where half of the data sits inside the interquartile range. That's how it varies from the median. Well, now we're going to learn a different measure of spread called standard deviation. It measures variance from the mean. All right, how the data varies from the mean. Now, when a data display is symmetric and bell-shaped, the shape is said to have a normal distribution. And if you look at the set of data right here, this has a normal distribution right here. All right, 7, then 2, 1 7, then 2 8s, then 3 9s, and 4 10s, like that. 3 11s, 2 12s, and 1 13. All right, think about when we rolled 2 dice. We had kind of a normal distribution when we kept track of the total of 2 dice. Oops, I'm going to move myself around here. That's when data is normally distributed. Again, when data is normally distributed, the most useful measure of spread is the standard deviation. Okay? Again, it shows how data varies from the mean. And remember what the mean is. It's the average value from the set of data. You sum up all the point values and then divide by the number of points. All right, that gives you the mean. And you can see here how we can measure 1 standard deviation from the mean, 2 standard deviations from the mean, 3 standard deviations from the mean, just by adding or subtracting values from the mean. Guys, standard deviation, it does have a formula. It's a big, long formula. All right? You can calculate using a table. It's a long calculation because you have to add up. This sigma symbol right here means add them up, sum them all up. So y'all, when we make the table, we have to take the average and how far away each data point is from the average, and then square it. Keep track of all those points, then add them all up, and then divide by the number of points, and then take the square root, or it takes a while. So we're going to use Desmos or the graphing calculator, either one. Now guys, actually there are 2 formulas for standard deviation. One of them is if you're measuring an entire population. And one of them is if you're just taking a sample of that population. I just want you to know that. There's actually 2 formulas, okay? And don't worry, we'll learn about both. And we'll know which one to use. Guys, the last thing, if you notice here, the standard deviation for brand A, these are brand A and brand B, okay? The standard deviation is less for brand A, 75.5 hours, right here, see that? And here the standard deviation for brand B is over 90 hours. What that means is brand A actually has more predictability to it. Less variance or a smaller standard deviation means it's more predictable. Okay? Guys, next, please complete the homework assignment in the purple folder. The warm-up for tomorrow. All right, sorry about that. I had to change it. Guys, the warm-up for tomorrow, it's matching these vocabulary words with their definition. Normal distribution, standard deviation, variance, and mean. Those are the 4 words, okay? All right, that's it, guys. Please do that, and we'll see you tomorrow. Thanks.